All right, you tried some problems out of section 10.5, and here are some answers for you. And I had a couple people come by and want to, ask a couple questions, but really nobody submitted any questions to be gone over. Um, 3, 4, and 5, I think, pretty straightforward applications of theorem 1011. Like on number 3, you have an angle formed by a chord and a tangent. That means the arc will be twice the angle. So that would be 130, and so on and so on. Number 6, the diagram to the right is not drawn to scale. Now, think about what that means. That means it looks like x is less than 90, but if it's not drawn to scale, you can't bank on that. So in the SAT, they always tell you it will be drawn to scale, but be careful. AB is a chord that is not a diameter, so we know we don't have semicircles. Let line M be tangent to the circle. And so we know that 2 times x is this relationship, and we know that the supplement of x would be 2 times that value would be this. What do they want to know? They want to know if angle x is less than 90, uh, greater than 90, equal to 90. Well, we know it's not equal to 90 because they told us AB was not a diameter, or if it's just not equal to 90. Well, I think that's really all we can tell, because it did say that it's not drawn to scale, so we don't know if x is greater or equal to 90. We just know it's not equal to 90, and so that one should be D. You really had to think about the words that we're using on that problem. Number 7 through 12 were really the big problems out of this assignment. They got into theorems 1012 and 1013, which talked about intersections either inside or outside of a circle and the angle relationships they have. As I said, nobody really asked a lot of questions on those. I could probably go through a couple of them for you. Number 13 was another good multiple choice question that you might see like on an ACT text that goes through that type of information. So these were all kind of the same thing. After 13, what do you do? 16, 18, 22, and 23. Okay. So here's number 8, kind of worked out for you. Um, we know that linear angles are supplementary, and so that's why I'm able to get this angle right here. And then when the intersection is inside the circle, I need to take the 2 arcs and then average them to get the angle. Well, in this case, I know the angle, I don't know one of the arcs. So I still set that equation up. I still say I'm going to take 2 arc measures, add them together, divide by 2, or multiply by 1/2, right? So that it equal to the angle. So I multiplied both sides by 2 and subtracted 45 to get that answer. You could do this one without that theorem if you were willing to, add a chord in, because then you could do, half of 45 over here. You could get to 122.5 here, and then subtract those from 180 to get angle G, and then double angle G to get angle X, and it would still give you the same answer, but it's a lot more work. The formula is much more efficient. Here's number 9. We have the same situation, 2 chords intersecting inside of a circle. So I know that the sum of the 2 arcs, these 2 arcs, okay, the sum of those arcs divided by 2 or multiplied by 1/2 is going to be equal to this angle. The problem is they didn't give me that angle, and that's, I think, where a couple people were getting tripped up. They saw the angle x down here, but they didn't really know how to use this. The angle x is not the angle that's intersecting these arcs. The angle x would be intersecting these arcs. And so what we needed to do is think about how I could name this angle right here in terms of x. And because of the linear relationship that we have, I just say, well, that's the supplement of x, right? Linear angles are supplementary, so 180 minus x. And that's what allows me to set up this equation. 1/2 of, I'll clean this up a little bit for you. 1/2 of 30 plus 2x minus 30 is equal to this unknown angle in here, which is x, which is 180 minus x. And that's how I would set it up. I would set that up like this right here. Now, if by chance you didn't know how to write that, and you said, well, I'm gonna write it as another variable altogether. Usually, you can't solve an equation with two variables, right? But because this side over here simplifies to just an x, we know that x and y have to be equal to each other. And the only way that can happen with linear angles is if they're both 90. We actually have a theorem that says that if angles are congruent and linear, that they have to be perpendicular. And so that's another way to do it, but that's, I think, the way that we have over here is much more algebraically and geometrically sound. Okay. Number 10, we have this time an intersection outside the circle. So this time I'm going to do this difference of the two arcs. I'm going to take the big arc, I'm going to subtract the little arc, and then I'm going to divide by 2. And that's exactly what I did right here. I did the big arc minus the little arc. Instead of subtracting by 2, I multiplied by 1/2, same thing. And that's how we get 67 on that problem. Number 11, I would do the exact same way. It is not, it's not written out for you, but it's the same exact premise. The big arc right here, subtract, oops, I wrote that wrong, didn't I? Let's try that one more time. The big arc, 114, minus the little arc, which is x, divided by 2, or multiplied by 1/2, is equal to the angle, 29. That's the, when the intersection's outside the circle, you got to subtract. So I would multiply both sides by 2. I could subtract the 58 over this way. 141 minus 58 is, I think, 83. And then I could add the x to the other side, and I get x is equal to 83. If I did my math right in my head, that's the answer. I don't know if I did. Number 11 was 56. Of course I didn't do it right. Let me think of this for a second. It certainly helps when you write this number down correctly, doesn't it? This was a 114, and I wrote it as 141 again. I really want to write that as 141. So 114 minus 58 is an entirely different value, isn't it? It's going to be, I think, 58. So I think that makes more sense. Now we know why the answer is what it is. I probably should start doing these solutions videos before midnight, huh? Number 12 has a lot of algebra involved, but it's the same exact relationship. The intersection is outside the circle, so we're going to do big arc, subtract little arc, divide by 2 or multiply by 1/2, set it equal to the angle, right? So here's the big arc, 3x. Let's go through this like this. 3x minus 2, big arc, subtract the little arc, x plus 6. And then either multiply it by 1/2 or divide by 2, set it equal to the angle, which they told us up here was 34. Now, the biggest mistake on this one is going to come up here in a second. I mean, let's go ahead and multiply both sides by 2 to get rid of that 1/2. So that's where the, that's where the 68 comes from. But this is where it is right here. I have to subtract the x plus 6. And I bet you 1 out of every 3 people will forget that that negative sign has to be distributed. And so if you look at your work and you still had a plus 6 there, and then your answer ended up being wrong down here, you know why. You forgot to distribute that negative sign. Okay, so be careful with that. Other than that, it's combining like terms. 3x minus x is 2x, negative 2 minus 6 is negative 8. So add 8 to both sides, divide by 2, boom, and you are good to go. All right. Number 13 was that multiple choice question we talked about. In this figure with the tangent line L and the chords intersecting inside the circle, what is true, what is not true. Well, angle 1, it has to be half of 220 because it's a chord and a tangent, so it's half of that, just like the inscribed angle relationship. Half of 220 is 110, and it says angle 1 is 110. So that's actually not the answer, because remember, they want the one that is not true. Moving on from angle 1, let's look at angle 2. Angle 2 has to be half of 140. So angle 2 would have to be 70 degrees. And that's also a true statement. So get rid of B. What about angle 3? Well, angle 3 has to be the average of these two arcs, right? So 100 plus 60 is 160 divided by 2 is 80. Well, that's exactly what it's supposed to be. So that's not true. So I'm assuming number 4 is the one that's going to be false. Let's see here. Number 4 has to be the average of these two arcs, which 120 plus 80 is 200, and 200 divided by 2 is 100. Oh yeah, there it is right there, isn't it? So that is the one that was false. And that's the end of that problem. 15, I think we wanted to do a question on. 15, nope, actually 16, 18, 22, and 23. So 16, 18, I think I have a better picture of 16. These are concentric circles. And so what that means is these two circles have the same center, but different radii. And so what we have here is, it's kind of cool. It's a set of secant lines for the inner circle, but a set of chords for the larger circle. Okay, so if I just focus on the inner circle, I know that x minus 40 divided by 2 has to be equal to this angle right in here. Okay, but if I focus on the outer circle, it's actually 2 chords, so it's an inscribed angle. So it's half of 110. So half of 110 is 55. So this little angle in here is 55. And now I can move to the inner circle and set up the relationship x minus 40 divided by 2, right, is equal to that inner angle 55. So if I double each side and then add 40, I get my answer, 150. Now, can we generalize this formula for concentric circles? Anytime that we have 2 concentric circles and we have chords for the bigger circle that are secant, parts of secant lines for the larger circle, will it work? Of course we can. We know that this inner circle, if we go back to the outer circle, we know that the inscribed angle is half of the arc, which is C, so half of C, C over 2, or 1/2 C. And now I can go to the inner circle and do what I did over here, except instead of x minus 40 divided by 2, it's going to be b minus a divided by 2, or multiplied by 1/2. And so because both sides have a 1/2 on them, I can just make that go away. And that's a really nice little formula right there. B minus A is equal to C. Anytime you have concentric circles with this relationship. Now, realize that two chords for the big circle don't necessarily have to intersect um, the inner circle. But in this case, they do. And when they do, the difference of the difference of the inner core, the inner arcs, the big arc minus the little arc of the inner circle will always equal the arc of the outer circle. Very interesting. All right, number 18 was this little guy right here. Let's see if I have that one set up. I do. So this is just the formula 1013. It's going to be the big arc minus the little arc divided by 2 is equal to this guy. And so 40 is equal to 1/2 of the big arc 7x minus the little arc 3x, which is 1/2 of 4x. And so you get x is 20. And now they asked me to find the measurement of arc CD, which was, notice it's only 2 letters. So it can't be the major arc that goes around this way. That has to be the minor arc that wraps around this way. I think I would still plug it into the blue arc, which is a total of 10x, 7x plus 3x, 10x, to get that value. If I do 10x times 20, I get 200, but then I can very easily subtract that from 360 to get the CD is 160. Okay. And then what, 22 and 23? 22 and 23, we're just playing around with this diagram here. The wall is tangent to the circle, and then so we have a big circle, we have a tangent wall right here, and we have some secant segments, we have some chords, we have some inscribed angles, we have all kinds of stuff going on, we have some central angles. The first question was find A, B, and C. Well, let's just find as many angles as we can. Like the central angles are going to be pretty easy, right? This is going to be 80. The diameter is going to split us into a semicircle here. And so you could either use linear angles to get this as 100, or you could subtract and get 100 out here. Either way, these angles are hundreds. By the way, I think that's angle A right here is vertical with this 80. So angle A is 80 degrees. Fill in the 100 over here. Angle B is down here, so angle B is exterior. So I would actually have to do 80 subtract 30 divided by 2. So that would be 50, right? 50 degrees. And then when you divide that by 2, you get 25. So angle B down here should be 25 degrees. What about C? Oh, here's C over here. So C is, I'm assuming you're talking about angle X kind of. So, it has to be half of this 100, right? That's one way to get it, is using the tangent and the chord. So half of 100 is 50. But you could certainly have gotten it another way. You could have said that, let's find a triangle we can use. This is the diameter, so this is 100. So this is 80, or you could say, hey, this is central angle of 80, this is 80. So half of 80 is 40, so this inscribed angle is 40. So in this triangle right here, the missing angle is another 40. and then you, because of the tangent relationship with the wall, which we know tangent in a radius or perpendicular is 90. These are 90, and you could do 90 minus 40 to get 50. So that's a different way you could have gotten x without using the arc that was 100. And 23 says, if the wall is tangent to the circle, find x without using the measure of angle C. So I guess maybe angle C was actually the 40. So how could you find angle x without using this? Well, we just talked about how we know that this chord is 100, and that angle x has to be half of that arc. So that's exactly how you do 23. So this one was a little confusing just because it had too much junk going on inside of it. But that is the story. And if you have any further questions, feel free to ask tomorrow afternoon in our help session. I think you'll find the segment lecture coming up today could be much more challenging. So spend some time on that. Maybe check out some of the examples twice, rewind, and really check it over. I think 10.6 is definitely the most challenging section of this entire chapter. So let me know how I can help, and have a good one.